Welcome to today's webinar in the series Smart Cabinet Building. Smart Cabinet Building is an initiative to promote integrated approaches to digital cabinet manufacturing and assembly. Today's topic in our series is picking, labeling, and assembling terminal blocks. Today's presenters are Malte Zapf and Timo Tessin of Armbruster Engineering and Faisal Dogan from Weidmüller. Your microphones are muted. To ask questions, please submit them in writing using the question tool of GoToWebinar of the menu that you should have available. The webinar will be recorded and made available on the Smart Cabinet website in the aftermath of today's session. With that, I'm pleased to hand it over to Malte, Timo, and Faisal.
All right, so also welcome from my side. My name is Malte Zapf. I'm working at the sales department of Armbruster Engineering, and today we are talking about the topic picking, labeling, and assembling. I will be supported by my colleagues, Mr. Timo Tessin, also from Armbruster Engineering, and Mr. Faisal Dogan from Weidmüller. Before I get started with the topics of today, a quick reminder of what the Smart Cabinet Initiative is all about and what the goals are. Smart Cabinet Building is an initiative of 5 manufacturers from different sectors. You can see the individual companies on the picture here listed. In addition to the companies participating today, like Weidmüller and Armbruster Engineering, also the company Comax, a specialist for automated wire processing, the company Suken, responsible for digital engineering with the E3 series ECAD software family, and the company Invent Hoffmann, with a focus on modern automation systems, complete the initiative at the end. Today, as the title already indicates, we are moving in the areas of picking, here located in the picture in the logistic, the topic labeling, located here in the component labeling, and assembly here in the cabinet assembly area. Of course, the individual topics could also be used in other areas, but more about it later on. For those who do not know this graphic yet, this is an illustration of what is covered in the Smart Cabinet Initiative, all based on the digital twin, as you can see here in the middle. But the focus today is more output with the same team through automation and optimization of work steps. In the course of your and our work, we all face a wide variety of challenges every day. We have listed some of them here, which we accept and counteract with our initiative. Today, we are talking especially about the growing demand of quantity, the lack of qualified personnel, and increased documentation requirements. In the following, you will hear how we manage this. So now I would like to go deeper into the first topic, the picking process. And it's all about the right component at the right place at the right time. So our ELAM software can be used in various areas, as you can see here on this chart. I will go into more detail about the picking process, and my colleague, Mr. Tessin, will deal with the assembly process later in this webinar. And the other points, the testing and the information, will not be dealt with in more detail for today's webinar. So the question is, what do you get in the picking using the ELAM system? We already start here in the first point with a good receipt. Here we check the incoming components of completeness and correctness. Here we also can carry out various measuring procedures for our customers. With the connection of different kinds of devices, data can be recorded and can be checked by the system for correctness. Also, the exact storage location for the individual components can be defined. If necessary, a rework can be started, or components can be declared as blocked in this step. In any case, a batch number is directly identified at the good received, which directly brings us to the next topic, the batch recording. By scanning a barcode, we can find out directly from which batch the particular component is from and which workstation it is proceed. In the assembly process itself, it's also recorded which batch was used in which end product in order to ensure a complete traceability here as well. The Elam batch recording system enables our customers to link this to the respective batch via the scan code. Depending on the component, the Elam system can check which quantity has to be removed from the batch and the respective removal step. In the PLR, the product life cycle archive, as we call it in the system, data as, for example, quantity, multiple removals, batch number, material numbers, and also the remaining quantity can be recorded and stored in a database. The next point, the picking. For provision of components at the workstation, we can already use the Elam system in the warehouse to display the removal on, for example, a mobile device, and then automatically acknowledge it via scan. The software also optimizes the walking routes so that duplicate ways are avoided. In order to reduce search times and incorrect removals, you can also use a pick by light or a pick to light system in the warehouse. Depending on the components to be picked, the light indicates the correct location to the employee. With these modules, the pick to light modules, they can also be used to report impending shortages. Via the request button on the module, a message is automatically been sent to the responsible department. In most of the scenarios I named before, it is mandatory to set up an interface to the ERP system, so you do not have to insert all the informations manually into the system. For example, we can transfer part lists and or order data to the Elam system, and we also can report informations back, so from the Elam system back to your ERP system. In any of these cases, the use of the Elam system in order picking guarantees that you always have the right components in the right place at the right time to ensure a smooth assembly, as I named it before. So that's it from the picking part. For the next topic, the labeling, I will hand over to my colleague, Mr. Faisal Dogan.
Thank you, Malte, and also a warm welcome from my side. My name is Faisal Dogan, and I'm the product manager for our labeling system at Weidmuller. In the next minutes, I want to explain you a little bit the labeling procedure. But first, we want to start with some general normatives for electrical component labeling, which you might also know or already have heard. So first, it's the EN 60204, safety for machinery and electrical equipment on machines, which says that all housing, assemblies, control units, and components must be clearly identifiable with a reference mark as shown in the technical documentation. So the physical world needs to comply with the digital world. The next norm is the IEC 61439, the low voltage switchgear and control gear assemblies. There are the definitions of the safety requirements for electrical equipment. There it says it must be possible to identify specific circuits and their protective devices. Marking must be legible, permanent, and suitable for physical environment, and it must comply with the EN 81346. So here it says that the marking or the identification needs to be durable. And the EN 81346 marking method is the marking methodology for industrial system, plants, equipment, and industrial equipments. There it says that it must be understandable. So in summarize, marking and identification must be visible, durable, and understandable. So how is the equipment label ensured? So the process is that every customer or our customers need to make from an indeterminate component through the entire life cycle of the plant. So it starts from the engineering, and as soon the component gets an identification, it must be clearly identifiable. This can happen in various positions of the value add process of our customers, starting from the logistic, but also at the component assembly, how Malte previous showed. But also customers label their components very late in their process during the cabinet assembling or even during wiring. So the universal device labeling for components are the most tedious and time-consuming work steps in this process. Why? Because in the past, all these labels need to be written, they need to be peeled off, and they need to be positioned manually. This took a lot of time, so 25 up to 35 seconds. The readability was really bad, the error rate was very high, the accuracy was very low, and at the end, the result was a messy appearance of the cabinet. During the digitalization and also the new print solutions, we achieved, or the customer achieved, to reduce the time to print on DIN A4 sheets. So there was a label on a DIN A4 sheet, but still this peeling and positioning need to be done manually. There was still medium error rates. The accuracy was acceptable, and also the appearance was acceptable. But nevertheless, there was also the last year's improvement. The last years, customers more and more decided to go on thermal transfer printers to print the labels on a roll. The readability was good, but still there is at the moment a medium error rate with a medium accuracy and with an acceptable appearance. So what's the next step in this process? The THM Multimark Labeling Processing Center makes device labeling really easy. It has a laser-assisted alignment which allows fast and efficient labeling of the components. The label will be automatically print, peeled off, and apply, which allows a high repeatability. We reduce the time with the THM Multimark LPC to 3 to 5 seconds per label. The result is the best readability, low error rates, high accuracy, and a clear and best appearance. We want to show you 3 main use cases how you and our customers can use the THM Multimark LPC. So first use case would be a stop-free labeling, so that you are able to place the component below the laser and just start the print and apply process. Secondly, you also can place an already assembled rail below the laser, and you just move the rail to the position and start the labeling process. Finally, if you want to label always the same component with the same geometries, There you're able to use the stops and deactivate the laser, which allows a high repeatability. Now I want to show you a small video which shows these use cases in live. So here you can see how to switch on the laser. Then the laser will be shown on the component, and that's exactly the position where the label will fit on. Also, if you take a rail, just hold it below the laser projection, and printing and applying is just finished in 3 to 5 seconds based on the height of the component. And the last use case, which is shown now, is if you always have the same component, you can use these stops, but also the laser helps to adjust these stops. You fix a position with the screws, and then you can deactivate the laser and always use the same component. I hope you liked the small introduction of the THM Multimark LPC. Thank you for your attention, and now I will forward the word to Timo.
Yeah, thank you, Faisal. Also a warm welcome from me. My name is Timo Tessin, and I'm the Key Account Manager from Armbruster side at Smart Cabinet Building. And next, we are looking at the assembly with the LM system. So the LM system can be used in various areas. As Mr. Zapf has already introduced, one part is picking. Another part of our LM system is assembly. This is about process monitoring and evaluation. So this means providing information, collecting data from the process and evaluating it in real time. Also the controlled assembly. This means identifying and avoiding errors right during the process, as well as the tool connection and the zero error assembly. Assembly with the LM system can be part of an entire process chain, or it can be used as a single solution, like you can see here. This means that assembly with LM can be designed as part of an entirely assembly line, just like we are seeing here, or as a single workplace solution in which the entire process runs on only one workstation. If we take a closer look at a workstation with LM, the following process can be implemented and used here. For instance, a guide. So we can guide the worker, show something step by step. This is done via a pick by light or pick to light system, or for instance, via a bit removal system or devices. The next is the control. So record measured values and evaluate them. We also can use special functions like identify workers or record movements, or also projecting something right on the product or on the workplace. And lastly, documenting. That means saving in the database for traceability. Through the interaction of these different solutions, the LM system can be used to design the optimal assembly area for you. Next, we have a small video clip that we are showing now. So now we are looking at the cabinet assembly. In the beginning, the production order number needs to be scanned, so the LM system can generate the work instructions dynamically. The first step then is to scan the card, so the system knows where the parts for the picking are placed. And after that, it prints a label to identify the mounting plate later on and shows the position of the label on the mounting plate via projector. Then the worker has to pick the first component shown by the pick by light system and is also assisted by the electronic screwdriver. And the position of the component will be shown via the projection directly on the mounting plate, as we are seeing here. And then the worker can pick the next component and also assemble it on the mounting plate. You can also scan the serialized components for traceability and documentation. And then the worker can also pick pre-assembled terminal rails that have to be finished assembling on the mounting plate, as we are seeing here. And with this, the worker goes step by step through the dynamically generated work instruction. The system can also show pre-assembled and pre-wired components and show them where the components has to be placed. And lastly, we are making a picture of the just assembled mounting plate, so we have the finished assembly documented as well. And then the assembly is done. Okay, so if you need to contact us for any ideas or some questions, you can do this with our contact data you've seen here. We also have a website that we can point to. On this website, you will also find the latest webinars we've done in the past. So if you want to catch up with one of them, you are invited to do so. And you have also the complete general information of the smart cabinet building on our website. Okay, the next webinar is in September 28th. And the topic about that is some news about the E3 series. Yeah, and with that, I will give it back to Klaus Wiedemann for some open questions. And thank you very much for your attention.
Thank you very much for your presentation. Just looking into questions, it appears nothing has arrived. We'll leave it open for a second because we can see when people start typing. So, but it doesn't seem that any questions are coming in. So let's wait for another few seconds. With that, I would say I would like to thank you for your attention from our side as well, and invite you to the next presentation, which you can find, for which you will receive an invitation in due time. Thank you very much for your participation and see you next time. Good evening.